Dr. Sillett, I'm tired of this dull routine. I wish we could get out of this lab and put our knowledge to some good use.
Tis I, Dr. Sal M. Nella. With my genetically modified microbe, A. zambium, I can finally exact my revenge on Dr. Sillett. This will teach you to win the grant money that should have been mine. Now, if only you had an extra grant to save your precious turtles.
Dr. Sillett, I think something's wrong with the turtle pond.
This must be the work of Dr. Nella, my old grad school rival. This means he has released his deadly microbe, A. zambium, into the water supply. We need to deploy the exact amount of antibacterial into the pond immediately.
But Dr. Sillett, first we need to determine the exact amount of microbes in the water. How can we track the growth of this bacterium in the water supply?
There are two possible ways, fluorescence and absorbance, but I'm not sure.
But Dr. Sillett, how would those help us right now?
Great question. Computron, can you explain?
Absorption is when the energy of a wave is transferred to matter as it passes through. The amplitude of the wave decreases as its energy is absorbed by the medium. If all of the wave's energy is absorbed, the medium is opaque. Water becomes opaque with depth as it absorbs more water and more of light's energy. In addition, bodies of water often have algae, bacteria, and other particles / sediment that further decreases energy. This is described by the Beer-Lambert law, or Beer's law. The absorptive capacity of a dissolved substance depends on its concentration in a substance. I sub z is the intensity of light at a certain depth, while I sub naught is the intensity of light at the surface. X is the light extinction coefficient, and z is depth. We can take a sample of water and run it through the spectrophotometer. The spectrophotometer will measure the absorbance of the sample, which can be used to determine the number of microbes in the sample. Fluorescence occurs when an object spontaneously emits a burst of radiation after exciting radiation is extinguished. This burst of radiation is re-emitted energy converted from absorbed radiation. This means it can only occur after absorbance has already occurred. This can be seen in the following graph. Fluorescence can only occur at lower frequencies than the incident radiation, as some energy is always dissipated to its surroundings. Water can accept high amounts of energy, having a quenching effect on fluorescence. This means that the wavelength will always be longer, often resulting in visible light of oranges and green. Certain biological molecules fluoresce strongly, such as chlorophylls and the green fluorescent protein. The fluorescence intensity of such molecules can be measured using a machine such as a spectrophotometer.
Rats! I was going to measure the amount of chlorophyll in the water to determine the amount of bacteria, but I forgot A. zambium doesn't have chlorophyll, as it is not photosynthetic. We'll have to use absorbance instead. Quickly, to the pond!
Finally, we know exactly how much A. zambium is in the water, and just in time.
Exactly. Now we just need to go save the turtles in the nick of time.
Congrats, Dr. Sillett, your work saved the day. Those turtles look pretty safe to me.
I couldn't have done it without you, or my knowledge of fluorescence and absorbance.